how to find how many hosts they are.
Hmm.
Yeah, we're
Okay.
talking about, yeah.
Okay. So you have got to understand what are the conversion of binary to decimal, decimal to binary. These were the things. Have
Okay.
yeah, and IP addresses are divided into two parts: network portion and the host portion, and the
Yeah.
default subnet mask. Those and all. Have you attended the class?
Yes, I attended that one.
Okay. What is the default subnet mask for class A?
The subnet
This
class
one
for
you have
what?
attended. This one is
Yeah, I
clear.
attended this one, yes.
Okay. Just I
The
will scroll
ranges
up.
and
This is
mm,
clear. This
yes.
is over. Network portion and the host portion.
Yes.
Okay. This one, network address and the broadcast address.
I think I disconnected around here.
Okay. So up to here it is clear. Number
Yes.
of valid host addresses, class A, class B.
Mm.
Junaid, I'm going to repeat from here. Is it problem for you or shall I repeat? Okay. Okay. Yeah, Isaac. Okay, let me cover from here. Okay. See, this
Yeah.
is a class C IP address. So class C
Mm.
IP address. So the example for class C, what is the number starts from class C? What is the IP address which starts from class C? It's from 192.
192.168.
Yeah, 192.168, right? That is a private IP address
Mm.
we are going to start. So that is the example here it is given. So 192.168 1.0 if you take here, the first address itself, it is 1.0. 1.0. Can I assign any IP address, 0 as an IP address to any of the hosts? Is it possible
Mm.
for me to assign 0?
No.
No. This is not valid IP address. This will be used as a network address. Okay.
Yeah.
Next IP address starts from 1.1, 1.2, 1.3, keep on moving like 253, 254. And the last IP address is 192.168, 1.255 is the last address. Okay.
Mm.
So the total IP address in class C, you will be getting how much? 256, right?
Yeah.
2 power 8.
7
See,
or
yeah.
8.
What is the subnet mask for class C?
255, 255, 255,
255
0.
dot 255 dot 255 dot 0. How many
0. Yeah.
hosts is available here? 2 power 8, which is equal to 256, right?
Yes.
How many zeros are there? 2 power 8 zeros are there, right? So if I have the place value for that, how many I am getting? 256 host addresses are there available. That means
Yeah.
for 2 power 8, 256 IP addresses. You can calculate from 0 to 255. Will I get 256? Yes?
Yes.
Yeah. Okay. So in that, what we are going to do, 1.0 is a network address. We are not going to assign this for any of the user. Okay.
Yeah.
And the last address of the range 1.255 that will be named as broadcast address. This is also not going to assign for any of the host in a network. Whereas in between 1.0 and 1.255, that is 1.1 to 1.254, we will be getting altogether 254 IP addresses. So we are going to escalate 1.0 and 1.2. How many IP addresses in 256? How many IP addresses we are not using? Two,
2.
two addresses we are not using, right? Which
Mm.
is that address? First address and the last IP address.
Last.
Yeah.
Yeah.
For the 256 minus 2, if I give, I will be getting 254. This 254 is a valid IP address. Clear?
Yeah. Clear.
Okay, now you need to understand what is network address and what is broadcast address, correct? In the same thing, in one class B, 172.16.0.0 is a one network, that is a class B, which starts from IP, and the last IP is 172.16.255.255. The first IP address is considered as a network address. The last IP address is considered as a broadcast address. These addresses we call as reserved IP addresses. Clear? Okay. See,
Yes, clear.
first and last address in each range are reserved for network ID and the broadcast ID. It cannot
Hmm.
assign these addresses to any of the devices in the network. Got it?
Yes, got it.
Yeah. So next thing here, this is for class A. Class A range starts from 10.0.0.0 and ends with 10.255.255.255. So this is on single network. In a single network, the first is reserved for network and the last is reserved for broadcast addresses. Okay.
Hmm.
So now we are going to understand what is network and what is broadcast address. For example, let me say I have these are the routers and here I have connected with the switch and here I have connected with the end users. So these are the users. So let me say
Hmm.
I have three routers. This is one topology and here I have connected with some users. Okay, switch. So let me say here I am using here 192.168.1.0. Here 192.168.2.0, 192.168.3.0. Is the same IP address or different IP address? Same IP range or different IP range I have assigned for the all three networks. How many networks I have in this topology? Do I have three networks?
Uh,
This is one
that's one
network.
network. Yeah.
This is second network. And this is
Yes.
third network,
Third
right?
network.
I
Yeah.
have three network here. So now for this network, I'm assigning IP address is 1.0 network, right?
Yeah.
And this for this, I'm using 192.168.2.0 network for this.
Yeah.
Suppose let me say this 1.0 means I'm going to use for this user 192.168.1.1,
Hmm.
1.2, 1.3. For here 2.1, 2.3. Here 3.1 and 3.3. Now I will say, let me say here I have 250 users. Here I have 250 users. Here I have 250 users. I can't write 250 users, so I am writing one or two users. That's it. Okay.
Yeah. Yeah.
So now, as a network administrator, or I'm a system administrator, I wanted to send a packet from one network to the another network. Now, what I will say, I say I wanted to just start, I'll do the ping. Ping from 192.168.1.1 is my source. This is my source IP. Okay, I wanted to ping to 1.3 network. Now how the data is going to be travel in a network. So the data will be traveled 1.1 reaches to switch 1. Switch 1 take that packet to this router. This router, okay, it will decide whether the network, by looking into the first three octet, whether this IP belongs to inside my network or should I take this packet to outside of the network, right? In this case, 192.168.1 is belongs to same network or different network? Isaac?
Yes. Sorry. Please repeat the question.
Yeah. See, 1.1 is the user. He wanted to send the information or send the data to 1.3 machine. Now, what will happen? He starts to ping. The data is going to be travel 1.1 to this switch to this router interface. Okay. This is connected with
Yes.
two interfaces. This is the inside network. This is connected to the outside network, right?
Hmm.
Now,
Yeah.
what it will do when the packet arrives at this router point, it will check the first 3 octet. 192.168.1.0 is belong to same network, or 1.1, or sorry, 1.3 is belong to same network or different network. This is the
Different.
destination.
Oh, same network.
Same network. Now what the router will do? Router will destinate this packet to this network itself, right? This
Yeah.
network itself. Suppose in the same 1.1 need to send packet to 192.168.2.1 machine. Now what will happen in this?
It will
It will take the
send it
packet to
to a,
this router, and here it will go to
yeah.
this. It will come here and it will reach out to this user, right?
Yeah.
It will reach out to this user. So now the question is how the router is going to decide, how it is going to identify, because it identifies the network address, right? See,
Yes.
1.0 I have not assigned. I want to ping for, let's see, 250 users here, here 250, here 250. So as a network administrator, I have 250 users. I wanted to check whether which are the machines are up, which are the machines are down. As a network user, can I go for 1.1 and start ping, 1.2 go and ping, 1.3 go and ping, 1.4 go and ping? Can I do this?
No, it's too
No.
much work.
Yeah, instead of that, he will use the broadcast address 192.168.1.255. He will be getting reply from other machines. He will identify which are the machine is up, which are the IP addresses has allocated. All these things he will, by using the broadcast IP, he will be going to notice, right?
Yeah.
And the packet need to see. Suppose the 3 dot network want to 192.168.3.1 machine. Let me take this machine. This machine want to reach out the destination, that is 1.1 machine. Now, how router is going to identify? Router identifies the network address. See here, this router is having the IP addresses. That means we say, one second. So here it has been advertised the IP addresses. So the network range has been advertised in the neighbor routers. So now the information of this router will be available on this router as well and this router as well. Same thing, vice versa. So the information will be, each and every network's information will be available on all the routers. Based on that, it looks into the network. Suppose say 192.168.3.1 need to reach out with 1.1. So what it will do? It will check out the routing table. In the routing table, see 3.0 network is there, 2.0 network is there, 1.0 network is there. So 1.0 network, it has to take the packet. So now it will go on, it will transfer the information data to this router. So this router is having a routing table, 1.0 network is available. Looking into that, it transfer again 1.0 network where it is available. So here. So now 1.0 it will check. It will not check the host ID 1.1. So first it will check with the network ID. Then it will search out for the host ID. Got it?
Yes.
First it has to check with the network ID. Then it will identify who is the host. So that is how the data is going to be distributed over the network. Clear?
Clear.
So your network ID means the first IP of the range, all zeros in the host portion. You can see. So suppose
Yeah.
if I say class C 2 power 8 bits are referred for host portion. That means all zeros, right?
Yeah.
And reserved for identify complete network. To identify the complete network, it is reserved. And cannot assign this address to any device in the network. Only valid IP addresses are assigned to hosts or clients. Okay, this is
Yeah.
clear.
Clear.
Next, broadcast. Again, I have told broadcast how it is going to used. So last IP address of the range, all ones in the host portion. So here 255. This is all ones in the host portion. used to send broadcast to all within the same network cannot assign this address to any device in the network. Only valid IP addresses are assigned. Okay.
Yeah.
Going to the next one. So we have a subnet mask. Why we use a subnet mask? Subnet mask, it will allow us to identify the network and the host portion, right? If
Yeah.
all ones, if one in the network portion, that represents the network. If zero in the host portion, zero represents the host, one represents the network. Correct? So we
Correct.
have already gone through this with what are the default subnet mask for the class A and B and C.
Pardon?
Yeah.
Yeah.
Did you call me?
Yeah. I thought you asked a question.
Yeah, yeah. What is the question?
I didn't hear you clearly.
No, I have not asked any question.
Okay. Okay.
Yeah. This the above you can read the slides. I will forward this document. Okay.
Okay. Thank you.
Yeah, this also reserved IP addresses you can see. This also you can go through. Private and public IP addresses we have discussed, right?
Yeah.
Yeah, no, this and all we have discussed, I think.
Uh, not with me.
Okay. You can refer to this. Huh?
Okay. I'll refer to that.
Yeah, you can refer to that. So here you have a test your skills. This also you should answer to me. You create a
Okay.
document and you can provide to us.
Okay.
So next we were going to concentrate on IPv4 subnetting. Okay. What is
Yeah.
subnetting? What are the different types of subnetting we can do? Junaid, you can concentrate from here. You will be getting the repetition. We were completed with class C. Now we are going to move for class B and class C. We will complete it of today. Okay. Actually,
Yeah.
I had covered this one. Again, I'm going to repeat it for you. Fine.
Yeah.
So what is subnetting? So till now, here we have identified, sorry, we had come to know that we in a class
Hello.
C, how many hosts are available in
Hello.
class C?
Hello.
Hello?
Can you hear me?
Yeah, I can hear you. Who is talking?
I'm Junaid. Junaid.
Junaid. Okay, now you're audible?
Yeah.
Okay. Okay, you can communicate with me. If any questions, you can ask with me. Okay. So subnetting. So till now we had gone through that. Suppose if I say class C IP address, what is the how many number of host addresses were available in class C? Can you answer?
Number of hosts,
Yeah,
25
2 power 8, that is
to
256
56.
host was available, right?
Yeah.
Okay. So subnetting is nothing but is a logical subdivision of one single network into multiple smaller network. What is the reason we are going to do the subnetting? The answer is by using the subnetting, see, it was only when it was we were using IPv4, this was the uh, what to say? This was the idea to use the IPv4 subnetting to minimize the wastage of IP addresses. See, helps in minimizing the wastage of IP addresses. But if you question me, is this valid for today? Yes, of course, it is valid for today who are using IPv4 still now. Most of the companies are using IP version 4 addresses. They have not yet migrated IP version 6. Most of the company, they work on both IPv4 and IPv6. Few of the company, they have already migrated and they are working with IPv6. Okay. So this
Hmm.
is, yeah. So whenever, see what was the total IP addresses in IPv4? 4.3 billion IP addresses were available. How many is the total IPv4 addresses? But what is the population today? What is the world population today?
Is it 9 point something billion or 10?
Yes, let me say 8.3 billion or 9.7 billion, right?
Yeah.
So is it going to be sufficient for the current population? 4.3 billion IP addresses?
No.
It's not sufficient. That is why they have introduced with the IPv6. So this is about 32.4 trillion IP addresses. For the next 10 generation, there will be no shortage of any IP addresses. Okay.
Yeah.
That is the successor of IPv4. IPv6 is successor of IPv4. Whereas when IPv6 was not in the picture, but they wanted to use the IP address effectively. So for that, they were planned to do the subnetting. Because of using a subnetting, they could have control the wastage of IP addresses. That was the main agenda of doing subnetting. Clear?
Yeah, clear.
Yeah. So now what we are going to do? So as we know, if I start 192.168.1.0, the last IP is 192.168.1.255. Right? This was the IP addresses. Let me say
Yeah.
I am working for abc.com. I am working for abc.com. Now I have multiple uh, departments. I have multiple departments. So here you can look into this. Which are those department I have? I have accounts department, abc.com have account department, marketing department, sales department, and HR department. Okay. So now for account department, what are the required IP here? Required IP. 50 IP address for account department, right? Yes. Marketing, we need 50. 50 users are there. Sales, 50 users are there. HR, 50 users are there. Are you there, Isaac?
Yes, I'm here. Yeah.
Following me?
Yeah, I'm following.
Yeah. So required IP for accounts department, there are 50 users, though they need 50 IP addresses. Marketing also 50 IP, sales also 50 IP address, HR also 50 IP address. Now, the thing is, I can provide 192.168.1.0 to 1.255. But what is the problem? Each and everybody is going to use the same IP address so that the traffic in the network is going to be huge, right?
Yeah.
And each network, see, suppose this department, each department are going to be access each other's data. That
Yeah.
was the problem. Now, I wanted to keep the traffic separate, and also accounts should not access the marketing, market should not access sales, sales should not access HR, and vice versa. Clear?
Yeah.
So, in case of that, now what should I do? If I wanted to not access each other and the traffic should be not huge, then what was my solution? Then I have to go and assign the IP addresses in a different network. See, for accounts, if I go 1.0 network, for marketing 2.0 network, sales 3.0 network, HR 4.0 network. Now, both my requirement is got solved. That means traffic is also not huge, and also each and every users of that respective department users are not able to access the other department's data, right?
Yeah.
Okay. Suppose if I go with this solution, what is the problem? See, in this network, what are the total IP addresses we are getting? 256, but my requirement is 50. How much is going to be waste? 206 minus 2, that is overall 204 IP address is going to be waste. Yes?
Yes.
Here also. So 204 into 4. 800 IP addresses. Altogether, 800 IP addresses are going to be waste, right?
Yeah.
So to avoid this type of wastage of IP addressing, so they are going to perform a solution called subnetting. This is the process of subnetting. Got it?
Yeah, I got it.
Clear? Is there any doubt for you? Do you have any doubts, any questions?
No, no questions. I'm
Okay.
following.
Yeah. So now subnetting can be performed in two ways. One is FLSM and another one is VLSM. Okay. One is
Hmm.
FLSM, another one is VLSM. FLSM's the full form of FLSM is fixed length subnet mask. VLSM is variable length subnet mask. Subnet mask. Subnetting calculated based on the requirement of host in specific. Okay. So there is a
Hmm.
formula to identify what is my requirement. So to requirement of host, the formula we are going to use 2 power h minus 2. That is the formula. Okay, this is h.
Yeah.
Okay. Now what is FLSM and VLSM? So for example, suppose let me say in the above example, I'm using 192.168 1.0 here. What is the subnet mask for here? What is the subnet mask here? Can I
Uh,
write? Yeah, 255 dot
255
255 dot 255 dot 0.
0. Yeah.
Yes, right. Here
Yeah.
also same. Here also same. Here also
Yes.
same. Yes. So in the same way, if I divide the network equal part, fixed length subnet mask. Suppose let me say I have divided this 256 IP address into 4 parts divided by 4. How much we are getting? 64. That means this is one network. I say this is first network. This is second network. This is third network. And this is fourth network. In this 64, 256 divided by 4, 4 networks, 64 IP addresses. In each network we had got. Let me say how I'm going to assign. I say 192.168.1.02, 192.168.1.63. I'm going to give it for first network. Okay.
Yeah.
Again, 1.64 to 1.128. I give it for second network. Again, 1.127. 1.128 to 1.191. Give it for third network. Here 1.192 to 1.255. I give it for fourth network. Whereas for all the network, if I'm using 64, that means how many bits? 2 power 6. 2 power 6. That means the subnet mask is here. That is slash 26. I'll come to that, how you are going to understand. Okay. Slash
Yeah.
26. That is 2 bits are turned on 192. 192.168.1.128 plus 64. 192, I think. Yeah. 255.255.255.192 is the subnet mask for each. 255.255.192. This is the subnet mask for each. So this is fixed for all the network. We have 4 network. So for all the 4, this is a fixed subnet mask. Whereas in this case, see here I have 64 hosts. Here I have 32 hosts. Here I have 32 hosts. Here I have 128 hosts. So here this subnet mask is keep on varying. That is why it is called variable length subnet mask. This is clear,
Yes.
Junaid? So now look into this 2 power table. 2 power 1, the value of 2 power 1 is 2. You can Understand this, right?
Yeah.
Be familiar with these 2 power values. We will work for this. So 2 power 7 value 128, 2 power 664, 2 power 5 is 32, 2 power 8 256, 9 is 512. Okay, so like that we have 2 power 14, that is 16384. Have a look into that. We will work on that. Now, the question is, okay, we understood what is subnetting. Subnetting is helpful for minimizing the wastage of IP addresses and also it controls the traffic. These are the benefits of doing the subnetting. But what we are going to do subnetting and what the changes we are going to do in subnetting, how we are going to do the subnetting. This is the challenge, right? So now,
Yeah.
in this case, you can see converting host bits. What we do in subnetting, we are going to convert the host bits into network bits. That is going to be reducing the number of host bits. Okay. For example, here you can see, I say this is network, this is network, this is network, and this is host. I got to know here 8 bits, here 8 bits, here 8 bits. 8 plus 8 plus 8. How many bits? 24. Yes.
Yeah.
Network bits is 24 here. 1, 2, 3. 3 octet is network. Each octet consider 8 bits. 8 threes are 24. So network bits are 24 bits here. Yes. But
Yes.
how many host bits? This is for class C. We are talking for class C. This is for class C. How many host bits we have here? 8 bits for host. 8 bits for host. You should answer me.
Yeah. 8 bits for hosts.
Yeah, this is it. This is the default one as what we have learned. Now,
Yeah.
the thing is, as I'm going to do, as we are going to discuss converting host bits into network bits. Suppose, let me say, so this one is 8 bit, this is 8 bit, this is 8 bit. Up to here it is 24, right?
Yeah.
Network bits are 24. But here how many bits are turned on? 2
2.
bits. 24 plus 2, I can say 26 network bits.
Yeah.
This one, can I write in slash 26? This slash 26 is called CIDR notation. What we call this? CIDR notation. That means by default, subnet mask is 24, but the converted network bit is 2 here. So for 24 plus 2, I had added that instead of representing the subnet mask in 255.255.255.0, I am representing this in this manner. Clear?
Yeah.
So here this is the subnet mask for slash 26. That is 255.255.255.192. So that is slash 26. Next example we'll take. How many ones we have here? 24. How many converted bits we have? Plus 3. Can I write this slash 27?
Yes.
Because 1 is representing the network. 0 is representing the host. So here how many hosts I have? 6 host bit. Here 5 host bit. And here 4 host bit. So how many bits are converted here? 24 plus 4. That is equal to slash 28. Getting me?
Yeah.
Okay, suppose, okay, this is, you got to know how converting the host bit into the network bit. So this is the result. Now, here you can understand. Suppose if one bit is turned on, what is the, let me say for class C we are doing 255.255.255.0. That means slash 24 I can write. I can write in this way or I can write in this way. Both the ways I can write. Okay.
Yeah.
Okay. Next 255.255.255.128, which is equal to slash 25. Can I write this? That means 1 bit is a converted network bit. Got it?
Yeah.
Next, same thing. I'm going to use this same and 192, which is equal to slash 26. That means 2-bit is turned on. Done.
Yeah.
Here same, all 24 bits. And I'm going to write this one as 224. How many bits are turned on? 3-bit. Slash 27 can I write?
Yeah.
Okay, in the same way. This is slash 28. This is slash 29 slash 30 slash 31. And this is slash 32. This is some. I'm talking this for class C. That is why I'm using only the last octet here. Clear? Done?
Yeah, noted.
Yeah. Okay, now we got to understand that how to convert, how to do the subnetting, what are the different types of subnetting. So what we are going to do in FLSM, what is the reason we are using the subnetting, this and all we got to know. Now the thing is we have to work for that. We are working for class C. Okay.
Yeah.
Okay. So now I'm going to write the requirement. Requirement is 30 host. We'll take my requirement is 30 host or 40 host. Shall I take 40 host? Okay.
Yeah.
Okay. Now how to calculate this? Here you can look into the slide. See, FLSM, we are going to perform for class C. Requirement is 40 host. So first, I know how many number of bits are available. How many number of hosts is required. I know the detail, but I don't know how many networks and I don't know what IP address I have to assign. All these things I don't know all the details. Whereas I have to calculate. So here, first I should understand total number of hosts. So what is the total number of hosts? So for that, we have a so total number of hosts, how to calculate? I should say 2 power h minus 2, which is equal to what is the value? Now tell me, look into this chart here. 2 power value 40 hosts, which 2 power value is going to satisfy my 40 requirement. If I go 2 power 5, I have 32. How many I have? 32 hosts. Can I take this?
Yes.
How? I need 40, no?
No,
But
246.
available is 32. So this is not suitable.
Oh yeah,
Two
yeah.
four six. We can go
I should go with 2
2
raised to 6. That is
Yeah,
2
2
power
power
6. What
6.
is the value of 2 power 6?
64.
64. Yes. So now I use 2 power h value, which is equal to 2 raised to 6. What is the value of 2 raised to 6? 64.
64.
Right? In that,
Yeah.
we are going to do minus 2. Why? Because network address and the broadcast address I should delete or I should exclude, right? So
Yes.
62 is the valid IP address. How many? Valid IP address. Clear?
Yeah, clear.
Did I got number of hosts, total number of hosts, how many I got? That is a 2 raised to 6, which is 64 hosts are going to be get for 40. But still here it is going to per network, I'm going to waste with 24 IP addresses. That I cannot help. Okay. But
Yeah.
still it is minimized comparing to the 2 power 8. Okay, total number of subnetworks, how I am going to calculate. So here, total number of subnetworks, that is 2 raised to n. Okay. So now tell me here, see 1, 2, 3, 4, 5, 6, 7, 8. Look into this. In this, what I have done here, this was the one. This is the default one. Here we have 24 bits and 8 bits for host, 24 for network. Now what we did, we used this 6. This 6 has a host bits, right? And now what we did, we have converted these 2 bits. I am changing that 2 bits to this. Now, if I do like this, what is my subnet mask? Here, my subnet mask is 255.255.255.192. So this is the value, subnet mask. But total number of subnetworks, how many? 2 power n. 2 power n is nothing but 2 power 2. That is nothing but 2 power 2. What is the value of 2 power 2? What is the value of 2 power 2?
4.
Yeah. Can I
4.
write 4 subnets? Can I write 4 subnets here? Isaac,
Yeah.
Can I write 4 subnet? Are you following?
Yeah, I'm following. Yeah, you can write.
Yeah. So now what is the subnet mask for this? 255.255.255.192. And I
Yeah.
have to write the IP range now. So how to write the IP range? Solve for this one. I will just fix. Solve for class C. Requirement is 40 host. Okay. So how to write the IP
Yeah.
range? IP range I have to write. So that means one 192.168.1.0. How many subnetworks I have? 4 subnetwork, right? Yes.
Yeah.
For 1.0, add 64. The next network starts 192.168.1.64. Add 64 for that. What is the next
No, it's
network?
dot 128.
64 plus 64?
128.
128. Next network 192.168.1.128 plus 64?
192.
192. So this is the first network. This is the second network. This is the third network, and this is the fourth network. Now 192.168.1.63. 192.168.1.127 is the last IP. 192.168.1.191. 192.168.1.255. Did you understood this?
Yeah.
So this is the
Loud and
first
clear.
network. This is the first network. How many IPs we got? Here, 64. See, total number of hosts we got in each network, that is 64. Here I am getting 64 IP addresses. Here I am getting 64 IP address. Here I am going to get 64 IP address. This is the IP range. Clear?
Yeah, clear.
This is the IP range. Now I have to write valid IP range. How to write the valid IP range? See, 1.0 1.0 is represented as network address. 63 is represented as broadcast address. Then 1.1 to 192.162 is nothing but valid IP range for the first network. Again, in this, '64 is a network ID, starts from 65 and end with 126. This is for the second network. This is 64 is network ID, 127 is broadcast ID for that network. Clear?
Yeah, clear.
And for this network, you tell me now, which is the network ID and which is the valid IP range? What is the valid IP? 129.
Yeah.
What is the broadcast last IP of this range? 190. Right.
Yeah.
So here, what is the valid IP range? Starts from 192 means 193, and here ends with 254. So this is the valid IP. So what you need to do now? So you should say valid IP is all the four you need to paste. This one. Paste this and copy this. So like this, all this one, whatever I have written in the below, that one. For IP range, you have to write this 1.0 to 1.63, 1.64 to 1.27, 1.128 to 1.91, 1.92 to 1.254. And for first host ID, you should paste 1.1, 1.65, 1.129, and 1.93. This is for first host ID. Last host ID, you should write with 1.60. Tell me.
I didn't hear the question, sorry.
See, first host ID, which is the first host ID? 1.1, 1.65, 1.129, and 1.193 is the first host
Yeah,
ID. All the four you should write.
yeah,
Last host ID, 1.62, 126, 190,
yeah,
and 254 is the last host ID. Right?
yeah.
So, how many? 24 plus converted bit is how many? How many bits are converted bit here?
Yeah, is it 2?
2 bit. So, what is the slash value?
26.
Yes, CIDR value is /26. Okay.
Yeah,
Okay. Now another question I'm going to give it for you. You can work for that. You can go through this. See, this is what we had solved. 2 power h, we took 2 power 6, 64 minus 2, 62 is the valid. So here this is the default subnet mask, and here we have converted network bits which are 2. Okay.
yeah,
And what we did in the next? So required host is 6. Converted network bits. Total number of host bits minus required host bits. That means total number of host bit is 8. Required is 6. So available is 2. The 2 is what? Converted network bits. 2 power 2. Total n bit is which is equal to default n bits plus converted. That means 24 plus 2. That is /26. This is what we did, right?
yeah,
Okay. So next thing. Valid host per each subnet. 22 power h minus 2, 2 power 6 minus 2, 64 minus 2, which is 62. And 2 power n, which is 2 power 2, 4 subnets we got. So this is what the subnet mask, fixed length. In each network, we have a same subnet mask, 255.255.255.192. This is what we had solved now. Clear? This part is clear now?
yeah,
How to
clear.
calculate? So next thing, you calculate for the requirement is 30 host. You calculate and tell me. Can you perform this? I want you to do all these things. This one. This one, all you have. This 8 is there, no?
Yeah, we
Yes?
can do that.
Yeah, you do that. For 30 host, you do.
Should we write it in the chat?
Hmm?
Should we send it to the chat or?
Hmm. How are you doing?
Yeah, I've sent to the chat.
Yeah. Done?
I'm on number 4.
Hmm?
I've only done 1 to 3.
Ah, okay.
Yeah.
Junaid, I have given the questions. Have you done for that? Junaid?
Yes, yes.
Okay.
Hello.
Yeah, have you done for the questions which I have shared for you the in the
Yeah,
previous
only few minutes. I will share you on okay.
Hmm?
After completion, I will share it.
Ah, yeah, yeah. Okay. So this one requirement is for 30 host. So total number of host bits are 30. That means 2 power 5 value is going to be suitable, right? 2 power 5. What is the value of 2 power 5? 32. 32 minus 2, that is 30. Right? So
Yeah.
converted network bits 3. 2 power value 3.
8.
Yeah. So that is what was the 8. 8 subnets we get. So here I should change with 1. So 192 plus, sorry. Yeah, 192 plus 16. What is the value? 32, right?
Yeah.
224. This is the subnet mask. Next, IP range. So I have to write IP range. So how to write the IP range? 8 subnets I will be getting. So 1.0 to 1.0 is the first. Next, 1.32, right?
Yeah.
32 plus 32, 64.
64.
64 plus 32, 96, 96? Yes or
Yeah.
no? Right?
Yes.
Yeah.
Yeah.
Again, yeah. 96 plus 32,
8.
128, right?
8. Yeah.
Yeah. 128 plus 32,
160.
160. So that is 160. 160 plus 32,
192,
192 plus 32,
224.
24.
224. Visible, right?
Yeah.
So here I have to
Yeah.
write the last one. 1.0 to 1.31, right? 31. So here it is 30. 32. Here it is 63. Here it is 33. Here it is 62. Am I doing right?
Yeah.
Here it is 65. And here it is 190. Is this right? 96. Here it is 97. And what is the previous? 96 plus 127. Here it is 126. Is this right?
Yeah.
128 and 128 plus 159. This one. Here it is 129 and 158. Okay.
Yeah.
This one 161 and this one 191. This one 190. 192 and 193. This one 223. This one 222. Right?
Yeah.
This one 225 and this is 252. This is the IP range, valid IP. This is IP range and valid IP range. So here IP range, you should write for 8 networks. 1.0 to 1.31 is one network, 1.30 to 1.63 is second, 1.64 to 1.91 that third network, like that. Okay. And the valid, you should write. And next, first host ID is, you should write all this one, 1.1, 1.33, 1.65, 1.97, 1.29, all this. Last host ID, this one, 1.30, 1.62, 1.190, this one you have to write. Okay.
Yeah.
CIDR value /27. Clear?
Yeah. Clear.
So next one. You can solve for this 100 host. Next, we are going for class B. How we are going to perform for class B? Can you try this one? Junaid and Isaac, both of you should try for this. Can you people try this?
Yeah.
Will you try?
Yeah. I can try.
Requirement is 1000 host. For class B. I just rewrite here. Requirement is 1000 host. Solve for class B. Okay. Example I will give 172.16.0.0. So that means you can go with 1.0, like that, anything you can go. Can you work for this? Yes or no? You want me to show one? Or will you try?
We can try.
We will try it.
Yeah. Solve for class B. Requirement is 1000 host. Now start from here. Total number of host. So for class C, what is the default subnet mask? So here we have to change this one. Instead of this, I have to rewrite this with 000 and 000. Right? This is the default subnet mask. That means 16, 8 plus 8. 16 is for network bit, 16 is for host bit. Yes?
Yeah.
How you are going to perform for this? Now requirement is, shall I do or you are going to do?
We're doing it.
Hmm. over
Almost. The IP range,
yeah.
it's going to be very long to do actually.
Okay. I'll start this with Junaid, have you tried?
Yeah, I'm doing.
Hmm. Okay. Okay, look here. So now this is my requirement. So what is the 2 power value which is going to suit my requirement? So the 2 power value which is going to suit my requirement is that is should I go with 2 power 9 or 2 power 10? Which one I have to go with?
2 power 10.
2 power 10 is the valid, right? 2
Yeah.
power 10. Okay. So I write that with 2 power 10. So total number of hosts, which is 2 power 10. 2 power 10, which is equal to 1024 minus 2. 1024 minus 2, which is nothing but 1022, right?
Yeah.
Yeah. So now total number of subnetworks. How to calculate total number of subnetworks here? Host bits. See here. One thing you remember now. What is the second? Yeah. In class B, how many bits for network host bits? What is the default host bit?
16.
Is it 16 bit?
Yeah.
Yeah, this is the 16 bit for host bit. Here you can check, right? So, but
Yeah.
here, how many host bit I have used? 10, 8 plus 2, right? 10
Yeah.
up to here. Yes. So 1, 2, 3, 4, 5, 6. So that means 6 bits are turned on. What is the value of 6 bits if turned on? If 6 bits turned on, what is the value? Here. Where is 6 bit? Is this the one? 252? Can I take this? 1, 2, 3, 4, 5, 6 bit is turned on, right? So I
Yeah.
can take this. Okay. So now here, what you can do, where is that? Yeah. This one you turn on. 1.1 and this is the one. So here you write this 252.0. So what is the subnet mask here? 252.0. Is this right? Yes?
Yes,
Yeah.
yes.
Okay. So now total number of network bits. What is the 2 power n value? How many bits are converted network bits here? Out of 16. 2 power 6, 16 minus 10. Right?
6. Yeah.
Huh. 6 bits are the
6, 6.
converted. Yeah. What is 2 power 6 value? 2 raised to 6 value is what? Here?
64.
64. 64 subnets we got. How many subnets? This one I can't write. Simply I can show you. That's it. Right? Keep on. So in class C I can write. Whereas in class B and class A I cannot write. So this you understood?
Yeah.
Yeah. So we'll come here now. You can look into this. Yeah. So 2 power h, 2 power 10, 1024, 1022. So whereas my requirement is 1000, still 22 addresses are going to be his waste in each network that we cannot help. So here you can see 16 bit is the default host bits for class B. So in that we have converted the 6 bit. So that is network bits. So total 16 minus 10. So 6 bits are the converted network bits. So here you can see 16 plus 6 slash 22 is the CIDR value. Got it? 16 plus 6 is the CIDR value, that is slash 22. Got it?
Yeah.
Okay. Next thing. Valid host each subnet. 2 power h minus 2, 2 power 10. So this one we got 64 subnets. We had calculated this one. So that means 1022 hosts per subnet we had got. And range I have to write. So now you can see range based on each subnet. So this is the one. First network is 192.168.6.0.0. Next 192. See something here we get a block size. One more thing in class B and class A, to write the range, we have to identify the block size. How to identify the block size? Okay. So block size is nothing but we have a formula. Each block considers 256 addresses. Like that, number of blocks. How to calculate? So that is 2 power h divided by 256 is the formula. So for example, here you can see 2 power h value is what? 2 power 10. What is 2 power 10 value? That is 1024, right? Divided by 256, which is equal to 4 blocks we got. That means in one block, how many addresses? One block 256, second block 256, third block 256, fourth block 256. So each together 1024. Got this one? Got
Yeah.
this one? Yes?
Yeah.
Understood?
Yeah.
So here, what I can do, IP range, how I can write. Here I have to write with block size. Block size. What is the formula for block size? 2 power h divided by 256, which is equal to 1024 by 256, which is equal to 4 blocks, right?
Yeah.
4 blocks. So now the range, how I am going to write? One 172.16.0.0 is the first block, right?
Yeah.
Add 4 to that. 172.16.4.0. Okay. Again, 172.16.8.0. Again, 172.16.8 plus 4, 12.0. 172.16.12 plus 4. What is 12 plus 4?
16.
Hmm?
16.
16.0. Again, 172.168.16 plus 4, 20.0, 172.16, 168.24.0. So like this. So what is the end of this range? So for this 172.168. What is the previous number, previous IP for 4.0? Is this 3.255? Can I write this? Hello.
And sorry, my
Yeah.
network was bad.
4.0, the previous IP of this 4.0 is 3.255 is the range, right? For
Yeah.
this network. Yeah, that is the one. So now, what is the last IP of this? 172.168.8.0 previous IP. 7.255.
7.255. Yeah.
Yeah. Next, 172.168. Previous IP.
11.255.
Yes. For this,
15.255.
yes, good. For this,
19.255. 23.255.
yeah, like this. So how many
Yeah.
blocks we got? 4 blocks. That means I have written more here. So first 4 is the thing. 1 second. Sorry. This is the one. Clear?
Yeah.
4
Yeah,
blocks.
yes.
So in each block, how many IPs we get? 1024 IPs. So in this valid also we have to write. How to write the valid IP? How to write the valid IP? 0.123.254. Right?
254
Yeah.
yes.
Yeah. So in this, 4.1 to 4.40. 7.254. Right? So which is the first host ID? 0.1, 4.1, 8.1, 12.1. Last host ID? 3.254, 7.254, 11.254, 15.254. This is valid IP range. IP range return. CIDR is /22, right? Done. So this is how you need to write. This is clear? You can see.
Yes, it's clear.
0.1 like 1.0, 2.0. So this is the one. It keep on moving. Can you solve this same for 4,000 hosts? Do this one. Then you do it for class A. One for class A, one for class B. Will you do this?
Yeah, we will try.
Yeah. Go ahead. 4,000 hosts you solve.
We're doing for class B?
Uh,
4,000 hosts for class B or?
for class B, yes.
Okay.
Is that over? Hello?
Well, almost.
Yeah, good. Yeah, I like the range.
Easy or tough? Finding easy or tough?
Easy. Just a lot of thinking to do.
IP range is to
Yeah, you can look into this. Requirement for 4000 hosts, 2 power 12 is 4000. That means 4096. So 4094 is the valid range. So converted network bits are 4. That means 240 is the subnet mask. 255.255.240.0. Slash value is slash 2016 plus 4. Right? This all done?
yeah.
So now next thing is block size. What is the block size? 4096 by 2. How many subnets you got? 16 subnets. Here 64 subnets. See, sorry, here I got confused. 4 blocks means I stopped with 12.0 to 15.255, right? I should keep on writing up to 64 subnets. Sorry, I had got confused here. This one is clear? 64. Keep on writing 4 plus 4 plus 4 plus 4 up to 64 subnets I should write. Okay. I'm sorry for that. I had forgotten that. Here, 16 subnets we will get. So what is the block size? Block size is 16 blocks. So that is 16.0.02, 15.255 is one block, 16.02, 31, again 16.0, 32.0, 48.0, 64.0, 80.0, like that keep on up to 240.0. This is the range. Okay.
Yeah.
Yeah. So now try
I-
for class A. Same thing. You solve it for one class A. So then we'll go further. Requirement is 16,000 host for class A. Solve for that. Same thing. Block size also it comes here. Subnets, block size is important. You should identify the subnets and block size. 16,000 host. For class A, you solve 10.0.0.0 network.
Oh, I can't see the.
Hmm?
Is it 16,000?
Yeah, 16,000 hosts.
Okay.
How many bits for host here? Default host bits.
14.
Hmm?
14
18, no?
is
18. 18 or 14? 3 octet. 8 plus 8 plus 8. Twenty-four bits for host. Default host bit. Whereas here, converted. What is the 2 raised to value? 16. You can look into the formula. 24 minus 14. So 10 bits are the converted network bits. Over? Is this over?
IP.
You want me to?
range.
Yeah, I want me to explain or understood? Understood, right?
Isaac.
Where is he? Isaac is not there, huh?
Yeah.
He had left, huh?
Think so is not in there.
Okay.
Um,
Have you confused or it's understood?
it's understood only in IP range only I got confused.
IP range, huh?
Yeah.
Okay. See here. What is the block size here? 16,384. See, look into this. I am telling 16,384. 16,000 people, 16,000 employees. I wanted to provide IP address, right?
Yeah.
I have in one block 16,000 employees. For each and every person, I have to provide the IP addresses. So, number of networks and number of hosts. In which class it is more? Class A is more of number of hosts, right?
Yes.
Because we have 24 bits host bits are there. Whereas in class C, 8 bits are host. So which is more? Which is more? For class A, host bits are more.
Yes. Yes.
Okay. So for this is for 16,000, 2 power 14 is the suitable. So you are going to take 2 power 14 minus 2, that is 16,384 minus 2. 382 is the host. Here I need to find out the subnet. How you are going to find out the subnet? See, in the place of host bit, how many bits are converted? This is the one. 8. This is by default. This is the default one. 8 bits for network bits. Whereas here converted network bits is how much? 8 plus 2. That is here
10,
8.
10.
Yeah, here 8. Here 2. So this is 10. 8 plus 10. That is 18 bits or convert. So total network bits are 18 bits. That is /18. Can I write?
Yeah.
Okay. This is clear, no?
Yes.
This is clear. So next thing. So as per that, the subnet mask is 255.255.192.0. So total number of subnetwork is 1024 subnetwork are going to be get. In one subnetwork, I am getting 16,000 hosts. Got it?
Yes.
That means 16,382 IP addresses I have to provide in one subnetwork. Like that, how many subnetworks I should provide? 1,024 subnetworks I should provide. Clear?
Yeah.
Okay. So next thing. Each block consists 256 address. You got to know. In class C, 192.168 1.0 to 1.255 addresses means in one block, 256 IP addresses I will be getting. This is for sure you got to know, right?
Yeah.
So now, number of blocks 2 power h divided by 256. That means 2 power 14 slash 256. You get 64 blocks in one network, right?
Yeah.
So now, see, one block means what? 10.0.0.1 one IP address. Like that, if you are writing 10.0.0.255 is 1256 address. Shall I write? See here. 10.0.0.02 10.0.0.255. How many IP you get? 256 IP you get,
Yes.
right? Next, what is the next IP? 0 is over. 255 is over. Next, what is the continuation? 10.0.1.0 to 10.0.1.255. How many IP you get? 256. Right?
Yeah. Yes.
2.0 to 2.255. Again, 256 here. Huh? Yes or no?
Yeah. Yes.
So like that, you keep on continuing with 3.0, 4.0, 5.0, 6.0 until this finishes 255.0. What is the IP here? 10.0 dot. 1 second. Here 10.0 dot. This line should complete with 255 dot 255 until that this will not get turned on. Okay, so this is the last IP. This is the broadcast IP. That means here it will come 10.0 dot 255 dot 255. Next what? Again I should start here 10.1.0.0. Again this one 1.0.1, 1.0.2, like that it keep on moving. Again this octet should complete with 256. Again here what it will do? 10.1.0.0 is over. 10.1.1.0, 2.0. This has to complete with 256 bit. And next, again, this one will be going to turn with 2. That means 10.2.1.0. Again, this octet should complete with 256 addresses. That like this, keep on. That is the range we are going to write in that. This you got to know, right? This you have understood, right? So in the same way, 64 blocks it is telling. That means what you need to do. Suppose if I say 192.168.1.0, I'm going to add 64 for this last host ID, right? 64. Right?
Yeah.
64 IPs means I'm going to keep on adding like this. Whereas in this, I'm going to add the block. That's it. That means 10.0.0.0 add 64 blocks for this. So 64 blocks means where it will come. Can I add it here? I get in this only 256 IP addresses. Where I should add? Next I have to move to this octet only, no? 10.0.64.0. Yes or no?
Yes.
Okay. After 10.64.0, again add 64 for this. 10.0.128.0. Again add 64. 10.0.192.0. Yeah, again add 64. What is the value? 250. Here it completes with 255. 256 it will complete, right?
Yeah, 256.
That means here it will complete off. Next, adding 64. How I'm going to add? See, this place is completes of this 255 and this is the last IP. I should have again 64 for this means next which bit are going to turn on? So, sorry, which octet I should work with? This octet. Right?
Yeah.
Second octet. Now again it starts from where?
0.
1. This place is 1. 1.0.0. Again for 1.1.61. See, this is different IP, this is different IP again. 10.0.64 is different IP. 10.1.64 is different IP. Like this, keep on. The bits are going to be turned based on that octet respectively. Clear?
Yeah, it's clear.
Now understood how to write the IP range?
Yeah, definitely.
So your next is 32,000 host also you can solve. So you can solve for that. That day you have taken the screenshot, no? There only it is there for class A, class B and all. You can solve for that. Tomorrow, I'm going to take the class for VLSM. That is a 10-minute class. We will finish it off and we'll go for the new one. Okay? Fine?
Yeah.
Okay. Any doubts in the today's class?
No. Everything is clear.
Okay. You practice for class A, class B, class C. So solve for that. Then we will, if you have any doubt, we will clear it on the next class. Okay.
Can you share the document?
Yeah, I'll share with the Taj. He will share to you. Huh?
Okay, fine.
Okay then. Thank you.
Thank you.
Yeah, thank you.
Good
Bye bye.
night.
Yeah, bye. Good night.